Write any two factors. Write any two factors on which internal resistance of a cell depends. On which internal resistance of a cell depends. The reading on a high resistance voltmeter, the reading on a high resistance voltmeter, comma, when a cell is connected across it, when a cell is connected across it is 2.2 volt. When the terminals of the cell are also connected to a resistance, when the terminals of the cell are also connected to a resistance, of 5 ohm, resistance of 5 ohm, as shown in the circuit, the voltmeter reading drops to 1.8 volt. As shown in the figure, the voltmeter reading drops to 1.8 volt. The voltmeter reading drops to 1.8 volt. Find the internal resistance of the cell. First take down the figure also. I have a cell connected to a resistor. The resistor value is R is 5 ohm. And this is when connected to voltmeter, reads 1.8 volt. Let EMF of the cell is E. This terminal is plus minus. Now first read the question. Write any two factors on which the internal resistance of a cell depends. The reading on a high resistance voltmeter when a cell is connected across it is 2.2 volt. When the terminals of the cell are also connected to a resistance of 5 ohm as shown in the figure, the voltmeter reading drops to 1.8 volt. Find the internal resistance of the cell. First we will write what are the factors which determines the internal resistance of the cell. The internal resistance of a cell depends on first one, they have asked two factors. So first one is the concentration of electrolyte. concentration of electrolyte. And the second one, distance between the two electrodes. Two electrodes. The concentration of the electrolyte and the distance between the two electrodes. Now we need to find out the internal resistance of the cell. We'll write, let R be the internal resistance of the cell. Let E be the EMF of the cell. Now the first case is the reading on a high resistance voltmeter is 2.2 volt. That is the case when we don't have this external resistor R equal to 5 ohm. We have E and internal resistance R. It is not connected to any other circuit but only high resistance voltmeter. And given the voltmeter reads 2.2 volt. Cell is connected across 2.2 volt. The value of this voltmeter now is 2.2 volt. The high resistance voltmeter means that there is no current flowing through it, and hence we can say that this E, the EMF of the cell is equal to 2.2 volt. So you can just make a note here. The high resistance voltmeter means that the high resistance voltmeter means that no current will flow through it. Hence, there is no potential difference across it. Potential difference across it. So the reading shown by the high resistance voltmeter can be taken as the EMF of the cell. So the reading shown by the high resistance voltmeter can be taken as the EMF of the cell. So therefore, the EMF of the cell E equal to 2.2 volt. Now we have in the next class we have the potential difference across the cell as equal to 1.8 volt. So in the second case it is given that the terminal voltage across the cell when 5 ohm resistor 5 ohm when 5 ohm resistance R is connected across it is B equal to 1.8 volt. Now we have the relation between R, E and V as the internal resistance R equal to capital R, that is the external resistance, into E by V minus 1. R is given, that is 5 into 2.2 divided by 1.8 minus 1. Now let us calculate the value of this. This is equal to 5 into, take the common denominator, so we'll get 2.2 minus 1.8, that is 0.4 divided by 1.8. Now this is equal to 5 4s are 20, so this is 2 divided by 1.8, or it's equal to 10 by 9 ohm. The internal resistance R is equal to 10 by 9 ohm. The internal resistance R is equal to 10 divided by 9 ohm. Divided by 9 ohm. So in the first case, when there is no external resistor, the voltmeter reading gives the EMF of the cell, because it is a high resistance voltmeter, so the current through the voltmeter is negligible, and hence whatever the voltmeter reads, that is, we can take it as equal to the EMF of the cell. In the second case, when R is equal to 5 ohm, external resistor 5 ohm is connected, the voltmeter reading gives the terminal voltage. So then we can directly use the equation for internal resistance to find the value of internal resistance.